There we go. Sorry, Otto. We did 9.1 and 9.2. We're on to 9.3. Thank you for reminding me, Anton. I always forget to hit that. I think I get everything checked off and I forget to hit that. Okay. On to 9.3. So 9.3 is circles, right? There's two things that I want you to be able to do with a circle. One is if I gave you, for example, it's probably not even going to be this complex, but if I did, this is 9.3, number 27, okay? And I asked you to write an equation in standard form of a circle with the given radius whose center is at the origin. Okay, so for number 27, they tell you that the radius is at the square root of 15. Okay, so if you need to write an equation of a circle with a radius of 15, first you need to know what the equation of a circle is. Does anybody know what the equation of a circle is off the top of their head? There we go. Anton's got it. X squared plus y squared equals radius squared. Hey, Otto. This is the equation of a circle at the center, at the origin. So that's great. We are going to, all we have to do is if we know a certain radius, we just need to plug it in. So if our radius equals the square root of 15, this is what trips people up the most. My radius is the square root of 15, but I need to square that in order to have my equation. So my equation for this circle would actually be the square root of 15 squared, which would just be 15. So this would be my equation of my circle. Okay, if I gave you something like number 19, where we have a equation 4x squared plus 4y squared equals 128. And I wanted you to find the radius. We could do that too, right? We need to get it back looking like this, and then we know that this equals the radius squared. So in order to get this equation looking like this equation, we need to divide everything by 4, right? So we get x squared plus y squared equals 32, right? 128 divided by 4 should be 32. Okay, and then the radius squared will equal 32, or the radius equals the square root of 32. And if you want to, you could find out what that number is. Okay, I think those are pretty easy. I think that's probably the easiest of the section. Where it might get a little bit trickier is, for example, number 33. Okay, so number 33, oh, happy first day of spring, by the way, everybody. Yay. Number 33, we have a point, and it says, write the standard form for the equation of a circle that passes through the given point and whose center is at the origin. So this is on page 630. Write the standard form of an equation of the circle that passes through the given point and whose center is the origin. So when people get to this kind of question, usually they're like, what? So basically what they're asking is this. We have some point, which is -4, +3. We have this point out here. Okay, we'll draw it in black, okay? We know that this point is on our circle. So our circle goes around and it goes through this point right here at -4, 3. Okay, so we need to find the equation for the circle that goes through that point. So what do we need to find? We know our equation of a circle. Anton has it up there. It's x squared plus y squared equals radius squared, right? We need to figure out what that radius is. Well, the radius just is the distance from the center to any point. So this is your radius right here. How do you figure out what that radius is? You get a tiny ruler out and you look. Just kidding, you don't get a tiny ruler out. Don't do that, right? Distance formula, exactly, Anton. You use the distance formula, right? This is the distance between 2 points, and one of your points is 0, 0. So it makes it really easy. So the distance between the 2 points is the same as the radius, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so we have x2, which is -4 minus 0 squared. Hello, did that work again? Sorry, somehow it hit mute. That's really random. Okay, well, you missed my exciting voice talking about the distance formula. So basically, your distance formula equals your radius, which is this formula. When you plug it in, your other point is going to be 0, 0. So it's -4 minus 0 and 3 minus 0. And this one actually happens to be a nice, easy number, which is 4 squared plus 3 squared, which I just happen to know is going to be a nice number that's going to work out. So it'll be 16 plus 9, or the square root of 25, which is 5. So all that to say that your radius is 5. Okay, so the distance between these 2 points, or the radius, is 5. And so then if I were going to write my formula, which is what I need to do, my formula is going to be x squared plus y squared equals 5 squared, or x squared plus y squared equals 25. So this is your equation of your circle. Again, if you're not feeling super confident, you can always use your graphing calculator to help you out a little bit, right? So we just said that the formula is x squared plus y squared equals 25. Okay, so that's your circle that ends in 5. So in theory, -4, 3 should be on my circle. Not in theory. If I did it right, that should be on my circle, right? So I have to get my cursor right there, but -4, 3 is a point on my circle. So I know that I did that right. All right, how do we feel about circles? Not so bad, right? Cool. All right, so on to ellipses. So just a reminder, right? Reminder what an ellipse looks like. An ellipse is kind of like a squish circle, right? It has, instead of just having a radius, it has vertex. Well, there's two types of an ellipse. Sorry, there's a horizontal and a vertical ellipse. If we have a horizontal ellipse, there's 2 points that are called the vertex. Those are the main points of your ellipse. The ones that are on the shorter side are called your covertex. The side that, in this case, the horizontal side that has the vertex points also has 2 focus points. And those focus points aren't just like a random point. Remember, they actually, from these 2 focus points to any point on your ellipse, if you add the 2 distances together, it's always a constant number. Okay, you know it's an ellipse because it has this formula where you have your either your x squared or your y squared over some term squared equals 1. That's kind of your hint that it's an ellipse. And again, we'll have this sheet available for you in the background as a kind of cheat sheet for you. Okay. All right. So let's do number let's do number 13. And this is on 9.4, page 637, number 13. Okay. So let's do red. Okay. 9.4, number 13. My equation is 16x squared plus 25y squared equals 1600. Okay. So you're like, wait a second, Mrs. Ross, you just told me that all of my equations when they're on ellipse equals 1, and this one does not equal 1. Well, we can make an equation. Well, first of all, when you have an equation like this, how do you know when it's an ellipse or if it's a circle? How do you know the difference? Because we kind of had an equation that looked like this. We just did it 1 or 2 problems ago. So you know that this is an ellipse because there are different numbers in front of your x and your y. Okay, and the one that was a couple examples back, they had the same number, and that allows you, when you kind of modify or change your equation around, to get your x squared plus y squared equals something. When you don't have that balance of the x and the y squared, that they share the same number, then you know it's an ellipse. So we're in ellipse territory, and all of our formulas that have to do with ellipses equal 1. So what we're going to do is we're going to divide everything by 1600, because what that does is makes our last term 1, right? 1600 divided by 16 is 100, right? And I should know this off the top of my head. What is 1600 divided by 25? All right, calculator, 64. Okay, so now this is my equation of my ellipse that I'm kind of more comfortable with, right? So what do I want to do first? Well, I guess I should read what I'm supposed to be doing. I need to graph the equation, identify the vertices, co-vertices, and foci of the ellipse. Okay, so in order to do that, first I have to figure out what kind of ellipse this is going to be, right? So I notice, by the way, that my 100 100 is bigger than 64, and 100 is under my x squared. So that's going to help me decide what kind of ellipse that's going to be. So when your x term is bigger, that means that you're going to have a horizontal ellipse because your vertex is going to be longer on that side. So I know that I'm basically dealing with a horizontal ellipse, and I am going to even do this. I'm just going to steal this and put it right on here. There we go. So I know my ellipse is going to look like this. Now I just kind of have to figure out what all the pieces are going to be. Okay, so I want to find my vertices, my vertex, which are right here and here. Okay, so you notice your vertex are at a0 and negative a0, and a squared is under x squared. So I know that a squared is 100, or a is equal to plus or minus 10, right? So that tells me that my vertex are at plus or minus 10 and 0. Okay. My co-vertex then are at 0b and 0 negative b. And b squared is my number under my y squared. So b squared equals 64, or b equals 8. So my co-vertex are at 0 plus or minus 8. Okay. And then the last piece that I need to do is I need to find my foci, my focus points. All right. This is the part that I did not copy over, but it is on your notes. Remember how I said it's kind of hidden on the last page there? Just to kind of show you where it's at. It's right down here. And it tells you that the foci of the ellipse lie on the major axis at a distance of c units from the center, where c squared equals a squared minus b squared. Okay, so the foci kind of get their own little special thing. It's always true. It doesn't matter which version you use. The foci are at, well, I'll do my scratch work over here. So c squared equals a squared minus b squared. Okay, a squared is 100 minus b squared, which is 64, equals c squared. 100 minus 64 happens to be 36, right? Yep. And that means that c equals the square root of 36, which is 6. So my foci are on my major axis, which is my horizontal axis, and they are at negative and positive c and 0. So my foci are at plus or minus 6, 0. So for such a crazy looking number 13, it actually doesn't look too bad, right? So those are all my points. If I graph it, Desmos, right? I would recommend graphing your original equation. Always graph the original if you can, because then you know you haven't messed up. Okay, there's my ellipse that's off my screen. Okay, so my vertex should be at 10, 0, and negative 10, 0, and my co-vertex should be at 0, 8, and 0, negative 8. So we did something right, yay. No, we did it right. Okay, there is one more thing that I want to show you in this section. Okay, so what if instead of giving you the equation, they give you some points and ask you to write an equation with the characteristics. Okay, so for example, there's a couple in here. I don't remember which one's on the test, honestly. So I just looked at it, but I don't remember which way it is. So let's look at number 21. There is ones like this, but let's look at 21 first. So the vertex is at 0, 12. And the co-vertex, this is still in 9.4. The co-vertex is at 11, 0. So what I have to do is I have to decide what kind of ellipse this is going to be. So you'll notice before I even flip to my other paper, if I were to sketch this out, the vertex is at 0, 12. So that means that my bigger side is on my y-axis. So my ellipse is going to be a little bit bigger in my y-axis than it's going to be in my x-axis. They're going to be close because my co-vertex is at 11, 0. But this one is going to be at, doesn't like when I draw those, this one's going to be at 0, 12. So this one is actually going to be a vertical ellipse, and I can tell that because this number is bigger and that number is on the y-axis. Make sense? Okay, so I know that this is what it's going to look like because that number is bigger. So that means that my A is 12 and my B is 11, and this is my equation. Okay. Much better drawing than mine. So this means that my A is 12 and my B is 11. So my equation is going to be x squared plus, or x squared divided by b squared plus y squared divided by a squared equals 1. Okay, and if you want to simplify these, you can. X squared over 121 plus y squared over 144 equals 1. You could throw this, because we're kind of getting down on time, you could throw this into Desmos and see your ellipse should look like this, and you should have your vertex at 0, 12 and your co-vertex at 11, 0. Okay. If you look at number 23, let's see. Yeah, look at number 23. They give you that the vertex is at 0, 8, and that the foci, is at 0, 6. Well, again, since they told me that the vertex is at 0, 8, that means that my vertex is going to be a vertical ellipse, right? So I know that because this term is in the y spot, the A is in the y spot, that this has to be a vertical ellipse. And I know that my A has to equal 8. What I don't know is what B is, but they tell me what my foci is, my focus point, which is that C equals 6. So I know what my equation is going to be. I know my equation is going to be this, but I need to figure out what B is in order to write my equation. So how would I do that? I would have to use my C squared equals A squared minus B squared and plug these guys in and get that 6 squared equals 8 squared minus B squared, solve for B, and then use that in my equation. Okay, did that quick explanation of 23 work? Everything in here work? I know I'm rushing a little bit, but I just realized we only have a couple minutes left, so I want to do at least one hyperbola. All right. So let's make sure we at least get to 9.5. Thankfully, 9.6 and 9.7 should be pretty fresh in your brain since we did those two last. 9.5, though, I just want to make sure we get through that. So 9.5 is hyperbolas. So remember, hyperbolas are a lot like ellipses, even though they don't look anything alike. And the difference is that instead of kind of everything circling in around the focus point, everything's going to open out around the focus point. It's basically taking the focus point outside of the ellipse. It's also another way you can think of it is double parabola. Okay. The formulas for hyperbola look similar to the formulas for the ellipse with one big change. That is, instead of adding the two terms together, we subtract them. And when you talk about the two focus points, the distance from one focus point to the hyperbola to the other focus point, when you subtract those two distances, that's a constant instead of adding them. And then the way that we find c is a little bit different too. Instead of c squared equals a squared minus b squared, it's c squared equals a squared plus b squared. So basically, in a hyperbola, all the signs are flipped. If that makes sense. Okay. So if we wanted to do number 11, where it's and I'm on page 645, section 9.5. Oh, I closed Paint. Okay, number 11 is 9y squared minus 25x squared equals 225. Okay, when I see this equation, if it was all kind of mixed up, I would know it's a hyperbola just for two reasons. One is that these two terms are different, and then there's a negative right here. So hyperbola, right? Remember that all of your equations for the hyperbola, just like the ellipses, equal 1, kind of our standard equation. So what we're going to want to do is we're going to make this. Oh, we did 11 in class? Okay. 9. Let's switch to 9. I didn't want to do 13 because it's worked out. Okay, 9 is 4x squared minus y squared equals 256. Okay, same idea. I still know it's a hyperbola. It's also in the hyperbola section. I'm going to divide everything by 256 so that I can get it equal to 1. So this becomes 1. This is y squared over 256. And this is, let's see, 664. Okay, so this is a hyperbola. Yes, this is a hyperbola. Sorry, I was side calculating here. What is the square root of 256? I don't know that one off the top of my head. 16. It's 16. Okay. Okay, so now I need to figure out what kind of hyperbola this is going to be. Right? I have two hyperbola here. Sometimes I think with hyperbola, it's actually easier to start with the graph because it's flip-flopped what you would think. So just like an ellipse, you would think, oh, this number is bigger, so it's going to like control the situation. Well, I always forget this. We can actually just look at it because of the way it's written, right? It's x squared minus y squared, not y squared minus x squared. So we just know it's going to be a horizontal hyperbola. I always forget that that's the easiest trick to do. You can just look at it and see, right? So in this case, it's not necessarily the size of the number that controls it, it's the way the equation is written. All right, so now I'm going to figure out where my vertex and my focus points are and my co-vertex are, all right? So it says identify the vertex, foci, and asymptotes of the hyperbola. So that's kind of the new thing. All right, so we know that a squared equals 64 and that b squared equals 256, which means that a equals 8 and b equals 16. So your vertex are going to be at plus or minus 8, 0. Okay. I also need to identify the focus points. The focus points, right? The focus points are that c squared equals a squared plus b squared. So 64 plus 256 equals c squared. C squared equals 0 to 320. Or C equals, running out of time here, about 17.8. That does not seem right. What did I do wrong here? 64 plus 256. Yeah, 17.8 or 9. Okay, so your focus point is really far out there. So your vertex should be at 8, 0, but your focus is really far out there. So that means that your parabolas on either side are going to be really wide bowls because they're focusing really far away. Okay, that's where your focus are. Your asymptotes, that's the other thing that we didn't, this is kind of new for hyperbola. So your asymptotes are here. So if your equation is x squared minus y squared, right, it's a horizontal hyperbola, your asymptotes are at y equals plus or minus b over a times x. So let's do that really quickly. Y equals plus or minus b over a times x. That's where your asymptotes are. Okay, so plus or minus b is 16, a is 8 times x. So plus or minus 2x is where your asymptotes are. So let's graph this super quickly because I know that pretty much time is up here. Just to make sure that we got it right. So number 11 is 4x squared minus y squared. Oh, nope, not equals. That's pretty cool looking though. Minus y squared equals, we should have like a Desmos art day. Okay, so here's your hyperbola, right? Your focus should be at negative 8, 0 and 8, 0. Or sorry, your vertex, your focus are out here at 17 and 17. We should have an asymptote at y equals 2x and y equals negative 2x. And these we'll draw as dotted lines so you can see that they aren't actually part of the graph. Those are the asymptotes. So these are the values that your hyperbola gets really close to but never quite meets. You can see as you zoom out, it gets really close but never quite meets. Okay, sorry we didn't get through everything, but that should be get you through everything except those last two sections, which we recently did. So hopefully that was helpful to you guys. I am going to send the test out right now, so you should have that. And please let me know if you have any questions. Thanks, guys. Bye.